So we've learned about this long division algorithm for polynomials, and we've learned that it comes from essentially the same long division algorithm that we use for arithmetic. And you can review that if you want, it's in chapter R. But here's the question. Is there a shortcut? Because long division takes a while, right? And it's always nice when we can find shortcuts. Well, is there a shortcut for long division of polynomials? Remember, in arithmetic, there's this thing called short division. Let's look at an example of that. We have the number 19,564 divided by 4. Now, the long way to do it is so that's the long way, and then the short way. I'm going through this quickly since it's a review, hopefully. But the short way would be to say 19,564 divided by 4. Well, 4 is going to go into 19 4 times. We know that that's going to get us almost all the way there, but we're going to be missing 3, so our remainder is 3. Let's put our little 3 there. 4 goes into 35 8 times with a remainder again of 3, because 32 is 3 less than 35. 4 goes into 36 9 times with no remainder, so we don't have to worry about one there. And then 4 goes into 4 once. So that's the faster way to do it. It does exactly the same thing, but it's just a shorter process. And the thing about short division, if you'll remember from arithmetic, is that it only works when we're dealing with integers less than 10. So basically 1, 2, 3, 4, 5, 6, 7, 8, 9. If we're dividing by an integer less than 10, we can use short division. If we're dividing by 14, it's not going to work as well. It's going to be a lot more difficult, and we're probably better off using this algorithm. But the question I would pose to you today is, do we have a shortcut that we can use to do long division of polynomials, sort of like we can do long division of numbers in arithmetic using this short division algorithm? Well, let's take a look. Alright, let's revisit the long division algorithm for polynomials. And let's take an example like 3x cubed plus 11x squared minus 35x minus 75. Now let's divide all of that by x plus 5. Alright, the first thing we're going to do is see how many times x goes into 3x cubed. Well, that's just going to be 3x squared. Notice that our coefficient is the same because all we're going to do is multiply it by x, and we're going to get that. So no big deal there. Alright, 3x squared times x plus 5. Well, we can multiply 3x squared by x easily. We already did that. It's 3x cubed. Then 3x squared times 5 is going to be plus 15x. Now we're going to subtract, so we change the signs of both of these, and add. So 3x cubed minus 3x cubed, that's obviously going to cancel to 0. And then 11x squared minus 15x, oh, I'm sorry, this should be x squared because 3x squared times 5 is 15x squared. So 11x squared minus 15x squared is negative 4x squared. Alright, now, and then we're going to bring down the negative 35x. How many times does x go into negative 4x squared? Well, negative 4x, right? X times negative 4x is negative 4x squared. So let's multiply that out. Negative 4x squared, and then negative 4x times 5 is going to be negative 20x. And to subtract these, of course, we're going to change the signs of both of them and add. So we've got negative 4x squared plus 4x squared cancels to 0. Negative 35x plus 20x gives us negative 15x. And now we bring down the negative 75. Well, how many times does x go into negative 15x? Negative 15. Alright, negative 15 times x plus 5. Well, negative 15 times x is negative 15x, just like we said before. And negative 15 times 5 is negative 75. Alright, now we're going to subtract these. To subtract, of course, we just change the signs. We get negative 15x plus 15x. That cancels to 0. And then we've got negative 75 plus 75. That's also 0, so our remainder is 0. Alright, so that's the process for long division. And you'll notice that when we went through that process, I was saying a lot of the same things over and over again. things like that cancels to 0. So what are some things we can notice about ways to make this process faster? Well, there are 4 things that we can notice here. The first thing to notice is that each remainder's coefficient becomes the coefficient of the next term. What I mean by that is, first we had our 3x cubed, the coefficient is 3. Up here we got 3x squared, the coefficient is 3. That happens because of this x here. All we're doing is trying to see how many times x goes into it. There's no coefficient in front of x. Now this negative 4x squared, again, we're just dividing by x, so we're going to end up with negative 4x. Then we have this negative 15x. We just divided by x. The coefficient is still the same. It's still negative 15. So the first thing we noticed is that for all of these numbers, 3x cubed, negative 4x squared, and then negative 15x, the coefficient just goes straight up here. And then the second thing we notice is that the whole term, this 3x squared, is going to be the same as this one except just 1 degree lower. So here we have 3x cubed, here we have 3x squared. Negative 4x squared turns into just negative 4x, and then negative 15x, you just drop the x and get negative 15. The reason that's true is because we're just dividing by x again. So that's the second thing we noticed. The third thing we can notice is that we're subtracting needlessly. Like I said, these are all canceling to 0, right? So why do we bother subtracting 3x cubed? Why do we bother adding 4x squared, subtracting 15x, when we already know that that's just going to cancel to 0, 0, 0, right? So that's something that we can save time by not doing, possibly. And then the fourth thing that we noticed is that we're always changing the signs here. Each time we subtract, we just change the sign and then we add. So we're changing the sign, changing the sign, changing the sign. What if we were to just change the sign once? Is there a way we could do that? Well, let's think about all 4 of these things. I'm going to switch the paper so that I can work more easily here. Alright, first of all, we're going to set up our division problem this way. Now this is a little weird. It looks kind of funky, but it's alright. Just hang with me for a minute. Now we mentioned that each term up here is the same as the term down here, except the coefficient is just 1 lower. Now if we learn to expect that, we don't even need to worry about these x squared, x cubed. We can just worry about the coefficients alone. So let's take the coefficient 3, the coefficient 11, negative 35, and negative 75. We can just kind of imagine that we have an x cubed, x squared, x, and then no x there, right? So we'll just kind of imagine that. And then we have over here in our divisor, again, we can pretend this x doesn't exist because we know it's just an x. X's don't do a lot. We just have a 5 here. Now we're going to try to get our answer down here, underneath the whole thing. So up here it's above, here it's underneath. So it looks a little funky, but that's alright. It's just the way that we do this algorithm. Alright, the first thing we notice is that our coefficient is exactly the same up here as it is down here. So all we need to do really is just bring this 3 straight down. We can put that 3 there, and then instead of an x cubed, it's going to be an x squared, but we're just imagining those anyway, so we can imagine that this is x squared instead of x cubed. And then, of course, at the end of the process, we'll actually fill them in. Alright, now we took the 3x squared and multiplied it by x to get 3x cubed, then subtracted it and got 0. So really all this stuff didn't really even matter, multiplying it by x, multiplying it and then subtracting. We know we're just going to get 0. What we need to figure out is what happens when we multiply it by 5. That's where the interesting stuff happens, right? We multiplied it by 5 and then got 15x squared and then made that negative and then added these together. That's the important thing that we need to worry about. So we're not going to worry about multiplying this 3 here by x. There is no 3 anyway, right? Or there is no x anyway, so because we already got rid of that. What is going to happen though is we're going to multiply this 3 by 5. And so we'll multiply the 3 by 5 and put it under the 11. Just like it's 15. Now notice here we put the 15 under the 11 and then made that negative. Well, what would happen if we just made this 5 negative once and for all, and we don't have to worry anymore about making this 15 negative, because this would already be negative if we had already multiplied negative 5 by 3. So it's like we're subtracting a little early. We're making this negative, and then that negative is just going to apply to all of the subtraction. We just turn it into addition with a negative number. So we've got 15. And now the next thing we did, remember, was to add the 11x squared and the negative 15x squared together to get negative 4x squared. And then this negative 4x squared, the coefficient negative 4, just appears right up here. So we can just add this 11 and this negative 15 together. And since we know that the result is just going to appear right here, we can go ahead and put the result down here, negative 4. Remember, we're just working with the coefficients here. Now we have 5 times negative 4, I guess it's up here. 5 times negative 4 is negative 20, and then we turn to positive. Here we've got negative 5 times negative 4, and that already gives us a positive 20. Negative 35 plus 20. Here we had negative 35x plus 20x. So we're just going to add the coefficients together, and we get negative 15, just like we had down here. And again, since this negative 15 went up into the result, we just put it straight into the result without making that extra process happen. Again, we're going to multiply this 15 by x. It's going to give us 15x. Then we're going to subtract it. It's going to cancel to 0. And then we're going to multiply this negative 15 by 5. That's going to give us negative 75. When we subtract it, it's going to turn into positive 75. So we take this negative 15, multiply it by what's for us is already negative 5, and then we can just add it. So we get positive 75, add them together, and we get 0. Now, the last step in the process of synthetic division is to realize, okay, we were just imagining our coefficients here. We had a 3x cubed, 11x squared, negative 35x, negative 75, and we just kind of imagined those coefficients, because we're not really doing much with them. They stay in the same place the whole time. And then down here we're going to get 3x. Instead of cubed, everything is going to be 1 degree lower. Remember, we are dividing by x. We imagined an x here, but it really was there. We're dividing by it each time. So 3x cubed divided by x is going to be 3x squared minus 4x minus 15. So our coefficient is 1 degree. I'm sorry, not our coefficient. Our x term is 1 degree lower for each term than the term above it. Alright, so that's our final answer. 3x squared minus 4x minus 15. Same answer that we got up here, except the process is a lot faster, kind of like short division in arithmetic. Now, this process will not work in a few situations. It won't work if we have a coefficient in front of the x. It won't work that way because remember that the reason we were able to just kind of imagine this x here is because that's all it is. It's an x. The reason we were able to bring this coefficient 3 down here is because this is just going to be a 1 in front of the x. 3x cubed divided by 1x is just going to be 3x squared. On the other hand, 3x cubed divided by 3x is going to be x squared. That's something totally different, right? Or even worse, we could have negative 4x divided by 3x. It can get out of hand really fast if we have a coefficient in front of the x. The other thing we have to make sure we can't do is we can't have an exponent here. We can't have an exponent here because we were counting on the fact that it's just going to be an exponent of 1. That's why the exponent just goes down by 1 each time. If we have an exponent of 2 or 3 or higher, we're not going to be able to count on that, and then we won't have our 3x squared, then our 4x, then our 15. We won't have that nice progression there because we'll have something multiplied by x squared and then something multiplied by a constant. So we'll be skipping the x term. So we can't use a coefficient in front of the x. We can't do it if the x is raised to a power other than 1. But if we just have x plus or minus a constant, if that's our divisor, we can use synthetic division all we want. And if our divisor, remember our divisor was x plus 5 in this case, and we just turn the 5 negative. If our divisor were something like x minus 3, we could just turn the 3 positive and put it in front of the synthetic division. So that's all I've got today. I hope you enjoyed this video, and I hope that helps.